But the conclusion, I think, should not be that batteries or energy storage is a bad idea per se. So we need batteries to decarbonize the power sector and electrify transport and heating to overcome climate change.
Electric energy storage or battery storage is a key flexibility option for the success of the energy transition. However, these technologies must meet a wide range of requirements, such as low costs on the one hand and environmental impact on the other hand. Two things that often pose quite a challenge to successfully master both at the same time. And actually, usually, if there is a point of critique on the energy turnaround as such, or also the mobility transition, most of the times it actually focuses exactly on the sustainability impact of electric energy storage. So, what actually are the main areas of concern? How much substantial critique points are there behind it? And what might be some promising ways of mitigation? These are the topics for the coming minutes. Welcome to the Smartery podcast, a podcast for and with the creators of the new energy world. A world in which energy will be renewable, decentralized and digital, bringing together electricity, heat and mobility. Let us show you how we will get there and who will get us there. When it comes to the sustainability impact of products, it's usually best to ask a neutral party. Hence, my guest today is Florian Mayr of Apricum. Apricum is a globally active transaction advisory and strategy consulting firm dedicated to the cleantech industry. And Florian there is responsible for energy storage, green mobility, and digital energy activities. Welcome, Florian.
Thanks for having me.
Well, welcome, Florian. Great to have you on the podcast. This discussion has been part of the discussion, for example, of electric mobility from the very beginning. However, there seems to be an increasing scrutiny on the sustainability impact of energy storage. So what are the main areas of concern currently?
Yeah, I think there are concerns all along the battery value chain. And a lot of worries are already in the upstream segment of the value chain, so the raw material extraction for battery production. So here there are various aspects to consider. One of that is certainly the direct environmental impact of mines in general. So that can be local air, water and soil pollution in relation to the mining of lithium, nickel or also manganese.
And just if I can jump in there already, I think the usual image you have might be a complete open mine in Congo where they mine with the most basic of tools like shovels somewhere in the forest. Is that what we're talking about?
I mean, mining depends, the way of mining depends a lot on the mineral you're mining and also, of course, on the country. And so Congo is a good example because this is probably a country where basic international human rights expectations are often not implemented or enforced. And so here is what, in fact, 15 to 30% of cobalt mining in the Democratic Republic of Congo is done in the way you just described, so more in an artisanal, small-scale mining way. But there are also large-scale industrial mines done by global conglomerates, which probably apply different safety and also environmental standards. So it's not that mining per se is bad. So it highly depends on the individual case. Yes, so and that also you already mentioned or that already made me go to a second aspect on the raw material extraction, and this is the potential bad labor conditions a lot of people relate to mining, such as child labor, forms of forced labor, underpayment or general unsafe working conditions which might occur in various mining sites. And as I said, of course, depending also on the local standards in the countries where mining is applied.
Maybe if I may ask you, so how big is the percentage of these kind of environmental conditions and also labor conditions? Because I think these are the images, if you're not from the industry, that you have in mind because you read about it in Spiegel Online or something. So how big of a part are these conditions really when it comes to the sourcing of material?
Oh, that's hard to say, to put a number next to it. But I mean, it's an absolute righteous concern. So if we start with the environmental impact, I mean, this can be, again, also various aspects to that. For example, lithium is mined in different ways. And if it's a salar-based mining, like it's done in the lithium triangle in Chile or in Argentina, that requires significant water consumption, which can have an impact on communities nearby. Or if we are looking at nickel, so the management of acid leaching processes and extraction, as it's done in the Philippines and Indonesia, also requires further scrutiny. And manganese mining is known for an intensive land use and may disperse airborne contaminants. So mining is always having an impact on the environment where it's done. So I think it's a matter how companies are, or the effort of companies, mining companies, to contain or to mitigate these impacts, and also, of course, governmental regulations to force mining companies to adhere to high sustainability standards.
We'll come to the solution in just a moment, but before we do that, let's complete the supply chain, also the life cycle of a battery. But let's come to battery cell manufacturing first. I heard of like an amazing fact that I was not aware of, that these huge soccer field large gigafactories actually need to be cooled down to minus 70 degrees to have the perfect dry air conditions to produce a cell. That does not sound very sustainable.
Yeah, in fact, the manufacturing of cells, but also the manufacturing of the active cathode materials such as NCA and NCM requires a lot of energy. And this is a lot of that is related to actually heat. So you need to purify the active materials and you need to dry the electrodes, and also you need heat for the dry room conditioning. And that makes actually manufacturing active materials and battery cells the most greenhouse gas emission intense steps of the entire battery value chain, so about 70%. And to put that into proportion, if you assume 2,600 gigawatt hours of battery production by 2030, that's a base case by the World Economic Forum, the battery value chain, excluding mining and refining, so just the steps we just addressed, would emit 150 megatons of CO2, and that's roughly the annual emissions of the Netherlands today. So this is indeed a significant greenhouse gas driver.
So that adds another challenge to the plate already. Very much looking forward to talking about the solution already, but let's complete the set of challenges first. Before we talk about that topic, a quick shout out to our partner for this episode. Today it's VDMA Battery Production, a sector group of the VDMA, which with its 3,300 member companies is the biggest industry association in Europe. The sector group aims on the production technology of batteries with a current focus on lithium-ion technology. VDMA Battery Production is the contact for all questions relating to battery mechanical engineering. Member companies of the sector group supply machines, systems, machine components, tools and services in the entire process chain of battery production, from raw material preparation, electrode production and cell assembly to battery module and pack production. If we look at the complete life cycle, I think the biggest question mark, of course, is in regards to recycling or even like implementing cradle-to-cradle approaches. I think even the automotive manufacturers have not really thought or solved that issue yet, right?
I mean, yes, there are certainly also concerns if the public thinks about, okay, what happens to all of these batteries, in particular after the end of use in, let's say, an electric vehicle after 7 years, and are they put all on are they disposed in the landfill, or to what extent can they be recycled and recollected? And I think here it's less a problem that technology is not available. It's more that the recollection rates, for example, are still pretty low. And also the amount of used batteries is still pretty low. So there are still not so many facilities in place, which makes the process more expensive. And also recycling, also recollections rates rather low. But nevertheless, for example, Volkswagen with their newest cell manufacturing plant in close to Salzgitter, they are applying the hydrometallurgical process here, which can recollect 95% or has a 95% recycling rate of the materials. And I think it's a good sign that also car manufacturers or battery manufacturers are thinking more cradle to cradle now and adding also recycling facilities to their manufacturing plant.
Okay, so Northvolt is going in that direction, Volkswagen is going in the direction. How are Chinese manufacturers or Tesla approaching this?
I mean, China is certainly, they're very good in recycling, actually. They're a front runner of recycling, doing much better than, for example, the US. I mean, they were early in the battery game. They also, of course, see the advantage. And by the way, I think that's also part of the game of car manufacturers, that you also then have access to raw materials, right? So that's also connected in a circular economy to the first step. So if you can do recycling efficiently and on a big scale, then you can do can cover a big share of your raw material requirements through these what's called urban mining. I really like that expression. And you are less reliant on, let's say, external sources for primary raw materials.
That is a conclusion that we often draw in the podcast, is that once there are economic factors behind it, not only environmental protection factors, that usually is a very promising driver. But yeah, so we have a big set of challenges from the very base of the supply chain in the manufacturing process, in the recycling process. Let's come to already existing solutions or promising ways of mitigating these issues. To what extent do you already see successful solutions being implemented? Let's maybe go exactly the same order again, and let's start at the base of the supply chain with, on the one hand, the extraction situation, but also the labor situation.
I'm happy to do so. I mean, I think it's important to see that all the concerns I just listed are absolutely justified. So it's not to just brush them off. There are a lot of problems along the battery value chain. But the conclusion, I think, should not be that batteries or energy storage is a bad idea per se. So we need batteries to decarbonize the power sector and electrify transport and heating to overcome climate change. But so the conclusion should rather be that sustainability issues along the value chain need to be addressed, to not indeed replace one evil with the other. And I think there are a lot of ways to deal with all of these challenges. So first of all, I think you can be more picky where to get your raw materials from, to start with that. So to focus on suppliers across the value chain, operating transparently and within accepted international practices, and thereby limiting the social and environmental impact. And several companies such as Volkswagen, BMW, Volvo, Tesla, you name it, started, for example, to apply blockchain tracking for cobalt sourcing, which increases transparency along the supply chain. And this is likely to put more pressure on raw material suppliers to improve sustainability along their processes and labor conditions. Here, I think the mining or raw material companies, they have plenty of options, right? Like using more renewable energy to power the mines, including the equipment such as using electric or, let's say, hydrogen-based trucks. And another way is to selectively switch to raw materials which are less concentrated in critical geographies in the first place. So, and I think here at Volkswagen's recent Power Day, I think it was very interesting to see that they selectively using different materials for the cathode materials. So they're using lithium iron phosphate material for the entry segment. This has a disadvantage of less energy density, but lithium iron and phosphate are also less crucial and coming from less crucial countries. High manganese for the volume segment, and the nickel manganese cobalt, which is the one which is closely linked to what's happened in Congo normally. This is only used for specific solutions. And last but not least, also recycling and second life usage can help to reduce the need for new material extraction altogether, as I already mentioned before.
There are a lot of interesting things in that I would like to break down also further along in the podcast. You mentioned the blockchain approach. We certainly have to talk about the actual environmental impact of these blockchain transactions themselves, but let's save that for the time being. Just quickly, if Volkswagen introduces a very transparent approach, does it just mean, it's like sitting on a waterbed? You have a bump here, but that means just some other manufacturer in another part of the world then picks up, in quotes, dirty raw material extraction. So is this issue really also being solved on a world scale?
I think that's a very good question, and I think you're addressing a very important point here. In Europe, obviously all of these Scandinavian manufacturing sites are based. Volkswagen is focusing at the moment with their cell manufacturing facilities. And also Tesla is starting their gigafab in Grünheide next to Berlin. I mean, here there's a strong push for building not only a battery industry, but also a sustainable one through the multi-billion euro funding programs such as the IPCEI or Battery 2030 Plus for sustainable innovation at every stage of the battery supply chain. And this is also to create a competitive advantage for European batteries centered around sustainability, as there's battery legislations with strict rules regarding sustainability of batteries used in Europe and to be in place as of 2023. So whoever wants to enter the European market needs to adhere to the high sustainability standards. So manufacturers from elsewhere who wants to sell their batteries in Europe, they have to basically bring proof that their CO2 footprint is within the range that the EC is foreseeing also for domestic manufacturers. So it's a level playing field here established for Europe. However, if Europe wants to export batteries or products based on batteries such as electric vehicles, that can of course be difficult then. So it makes it harder to compete in global markets without similar rewards for sustainable production. And also of course in the domestic markets of Europe, there is a downside because the sustainable battery production could of course also mean that the current cost down trends for batteries is slowed down. And this is also hampering then the competitiveness of batteries compared to non-battery alternatives, both for stationary storage and also mobile applications.
What would be your conclusion then be? Is Europe positioning itself smartly in regards to increasing demands for sustainable energy storage industry, or is it doing the wrong steps?
Mayr, who is the Federal Minister for Economic Affairs of Germany, he said, we will never produce the cheapest batteries in Europe, but we can produce the best, most efficient, and also most sustainable batteries. So I personally strongly believe in in a competitive edge here. I believe in a trend towards a greener economy also globally. And I think eventually other countries will also follow the lead then of Europe and establish similar regulations.
Which brings us back to the challenges in the manufacturing process. So is the zero CO2 battery cell production possible? And what would need to happen to get there?
I think it's in principle possible, but I think also most manufacturers use the term carbon neutral battery manufacturing these days for a reason, because this typically includes renewable or at least low carbon sources for electricity and even more important actually heat, but also includes offsetting what's left through carbon credits. So this would not include the previous steps in the supply chain, in particular mining, which cell manufacturers can only control to a certain extent. So I think a true zero CO2 cell production is certainly possible if all decarbonization levers would be pulled, but it's probably not realistic in the near term. But nevertheless, I think carbon neutrality seems to be a good first step that should be taken by all manufacturers. And we see that if you read through the news just of the last couple of months. I mean, Tesla's gigafabs using heat pumps and renewable energy. Mercedes is targeting carbon neutral production of its EQC by 2022. Northvolt Volkswagen aiming to achieve the world's lowest CO2 footprint in battery cell production, and so on and so on.
Wow, that does sound like quite a competition amongst the automotive manufacturers. Earlier, while we were talking, you also mentioned how some automotive manufacturers try to implement blockchain as means of creating transparency throughout the supply chain. Now, some blockchain transactions, specifically when you talk, for example, about Bitcoin, have an immense energy consumption per transaction. I think one transaction equals the energy consumption of a normal average household of 3 months. And that's not only a problem for Bitcoin, but for a lot of different blockchain applications. So do you think it's smart to use blockchain for monitoring the supply chain in an area where you're trying to already save energy?
Yeah, I mean, that's a good point you're addressing here, which is probably not looked at sufficiently. I think the main thing is that companies are trying to find ways to improve transparency and traceability along their supply chains. So that's similar to what is already widely applied, for example, in the diamond industry. So wherever like conflict minerals are applied, then and public scrutiny is increasing, then companies are forced to act. And I think blockchain-based technology has a lot of features that could help to create this transparency, to digitally record the physical transaction while, for example, cobalt moves along the chain, and make sure that it comes from a sustainable source, and also to keep track of the CO2 footprint. It's one of these applications where blockchain seems to be made for, but I think it's probably one option. And also, I think, I'm not an expert for blockchain, but to my understanding, energy intensity depends also on the verification method applied. If it's really this mining, this is always very energy intensive. And again, we should then make, of course, sure that we are not replacing one evil with the other.
So we're already at the end of the podcast, and to come to a conclusion, because we talked about some really significant challenges, you also showed some ways that these challenges are already being addressed. I think the big thing is comparing it to the alternative. So if you regard like the extraction of raw materials, the CO2 intensity in production, manufacturing, as well as then the cradle to cradle or the life cycle impact, how does it fare still in comparison to a traditional combustion engine driven vehicle?
Yeah, I think the advantage is certainly there. I think it depends a lot on the carbon intensity of the electricity mix of different countries. And we are not talking about production, but also specifically about the operation of the vehicle. So depending on what electricity you are charging your vehicle with. But yeah, depending on this electricity mix, the vehicle size, and also the use case, the CO2 advantage over the life cycle of an electric vehicle in most analysis I'm believing in ranges from 19 to 60% versus an ICE vehicle during the first life of the battery. So that means that an electric vehicle will have compensated for the relative CO2 disadvantages after driving approximately 24,000 kilometers on the road, at least in the case of a small vehicle in the EU. As I said, it depends on country and vehicle size. So I think the discussion whether e-mobility is more sustainable than ICE or can be more sustainable than ICE, I think that's a discussion we shouldn't have. I think we should try to pull all the levers to make it even more sustainable as it is already today. And always make sure that we are not replacing, let's say, one evil with the other.
Thanks, Florian. That was almost already a perfect closing statement. So the numbers you just shared for the base scenario for 2030 are very promising. You also mentioned that some automotive companies have a very good recycling rate in regards to the raw materials being used in electric energy storage with up to 95%. And I think putting that all together, one could say that yes, there are some significant challenges throughout the whole supply chain manufacturing process and life cycle of electric energy storage, but they are being solved. And as you said, also there's quite a competition amongst, for example, automotive companies being the biggest drivers in this area in outcompeting themselves in regards to the sustainability impact of their battery products. So thanks a lot for joining us for this episode, Florian.
Thank you very much for doing the interview.
Stay tuned for more episodes of the Smarter E podcast. For more information on sustainable battery and energy storage technologies, visit the EES Europe conference, where leading experts will delve into and discuss current topics in the battery and energy storage industry. Information can be found online at ees-europe.com/conference.